Chapter 4 gives you a better overview of what the significance of this and how we use it. And then Chapter 3, I consider more of a byproduct of the way we use it. Okay, anyway, so in particular, in Chapter 4, I want you to read 4.1 through 4.8. But I'm going to highlight Chapter 4.7 and 4.8, which is about UML, Unified Modeling Language. And the reason I'm highlighting that is because that's going to be in your homework. And I haven't updated the slides to use UML, but UML, I think, is something you'll encounter more frequently and professionally than you will some of the other kinds of modeling. UML is in widespread use in its ability to represent the unified modeling framework. Is modeling around object-oriented programming, so it's object-oriented, and also brought in the data modeling piece from entity relationships. So that's a good thing, and I'm gonna emphasize that, but not in the slides. I'm going to emphasize it in the homework. And Chapter 3 is normalization. Okay, so where we are on the homework. Homework 3 is scheduled to be released on Monday. What happened over the past couple of days is SQL Azure, whatever problems we were having before with SQL Azure. Oh, I'm over here. I'm going to stop with the slide there. Okay, there. Thank you. I don't remember. Whatever issues that SQL Azure or Azure was having in general with capacity, have eased off, and we've had pretty good success since then. Yesterday, I had spun up 2 different SQL Azure databases, and I know the TAs on my team and the TAs on the 344 team, they're feeling more comfortable about it. So we're going to release that on Monday. SQL Azure looks like it's going to be working. You may run into things if you want to start on it early to see, but basically go out and accept that SQL Azure invitation that came in email earlier in the week. Locally installed SQL Server remains a very good option, even though SQL Azure might be a little quicker to get started with, but it's going to be a lot slower, and you are limited in how much you can spend on it in terms of time. And every time you're using it, you're accumulating charges. And I think we've only put $50 in your account, which is not going to go all that far. You're going to be loading the same flights database that you are already getting quite familiar with in SQLite. And the first homework is let's move to a different platform. Let's move to a professional database management platform, which we'll be using then going forward, so we could demonstrate many more things. Your experience with SQLite, it's an easy, lightweight way to get started, but it's lacking a lot of features that you'll find in database management systems that we use that scale, basically. SQLite is a single user kind of thing. It's fine for what it is, but we're moving past that. And it has some peculiarities you've seen already in terms of syntax and sometimes doing things as limited data types. And all these are things that we will be working with going forward. Now, for homework 3, again, which will be released on Monday, you can pair off and form a team for the homework assignments going forward. So we're not going to assign you to a team. So if this is something you want to do and you know who to team up with, that's great. You'll be able to do that. If you've noticed on Gradescope, there is the ability for a team to make a single submission. Just have to identify yourself as a team, and then we get one grading, and it applies to both individuals of the team. There are a few of you that I'm a little worried about, but not quite yet, who don't necessarily have all of the CS143 prereq that we have. And we do have one homework assignment coming up that you'll be writing some Java, and you might not have a lot of Java in your background based on people that I talked to earlier, trying to get into the class before we started. So I was thinking about teaming you up with someone that did. So we'll help you find a teammate for those people. Now contact me. We'll figure out how we'll do this. So now teaming is going to be interesting, certainly, since you guys are probably hopefully practicing some social distancing, as they call it. Certainly, in the first homework, like homework 3, the teaming you could do could easily be accomplished by sharing a screen in Zoom. And the screen you're sharing is probably going to be the SQL Server Management Studio. I'll do a demo for you quickly. That's how you would do the development, probably the work. You'll find that very handy GUI once you get the hang of it, and I'll demo a little bit of it. Once you're getting to source code, you probably want to use GitHub. Now, where is my poll? What I was going to ask you guys is, I don't know how familiar you are with, so launch this poll, and they're launching a poll. And would you tell me if you have prior experience with GitHub? Mostly from your other class. That's good, that's good. No, a lot of you don't. Okay, well, here's the results on that. So we've been talking about that in our TA meetings. So probably, guys, we should figure out a way of having a GitHub session that people can go to, or do some training to get you up to speed on GitHub, because it's a sizable number. I don't want you to be penalized. But GitHub is basically a source code repository, and a source code repository gets very necessary whenever you have multiple people working on the same block of code. Yes, you could certainly use two to a team. You could certainly use Ed to advertise for a partner. That would be great. You can do, that might be a way of doing it. What do you think, guys? Would that work? Put something up there, just sort of advertise yourself.
I think we can have like a Google form, and then we can just like match up if they want to do randomly, or they can just like post if they want to partner.
Okay, that sounds good. Do you create like a pool is what you're thinking? That would be good. That would be good. Okay, that was noisy, whatever that was. Let me bring up SQL Server Management Studio for you, just to give you a quick kind of demo of what you're doing. You have 2 panes in SQL Server Management Studio. Well, first thing you have to do is you have to connect to the database. Connection is basically around security, your credentials, your authentication. That's the first thing that you're going to see associated with a database. That's a server mode database that's designed to be connected from multiple clients. So you have to have some authority around it, some security. There's whole layers and layers of security built into things like SQL Server. So this is the SQL Server Management Studio, and it's a GUI. If you played with SQL Studio Lite, that's a really light version of this. On the left, this is, I think the only thing I have loaded, oh no, I have a bunch of other databases here. Oh, I do, actually, I forget what I have. But I loaded the flight database here, whoops. And you get, who doesn't like me? It doesn't like me, am I not connected? Okay, I don't know what that is right now. You'll see a list of your tables. And for instance, here's the carriers. And it'll show you columns and keys and constraints and triggers and indexes and even statistics on them. And all of these things are things we're going to cover as we get deeper into the class. And this is what people that work with database management systems do work on. We'll also look briefly at programmability, which is the ability to turn this SQL language into, in effect, a programming language. This language in SQL Server is called T-SQL. I don't know the origin of that. Transact, I think, is because it was transaction oriented. We're going to get the transactions. And there's a whole lot of T-SQL. I'm not a wonderful T-SQL. I don't like the debugging experience, but this is also a debugger. If you have, and these are SQL scripts basically. So this is got a client, and the client also helps you do administration of the database. And it's got a number of things that we're not going to be looking at that much, but there you go. So for instance, flights, did it not like me looking at flights? Oh. So if you, here's a query against the flights database, the flights, and that was the carriers themselves. And you get something about the number of rows affected. And that was a top 1,000. I don't know if you can take this query. That's the nice thing about it. You can get rid of the top. Top is non-standard. And you could replace this with select, or there's only 2 columns in it. But let's just, out of curiosity, see how big this sucker is. And it is a total of about 1,600 rows. So I could have done a count, I could have done any of those kinds of things. So here you've got, this is a syntax editor for doing scripts. It knows the database that you're working with. It helps you with, I don't have to type the names of things. It'll syntax check it. It's pretty useful. So I'm not connected to this. What's that? Maybe I thought I was. So when you're in a script, you can execute pieces of a script at a time by highlighting it. And the first thing you tell, because I have a number of databases here, tell SQL Server what database you were looking at. When I imported this carriers database, I noticed that the what I noticed was, because we were pulling it in on an import utility using a CSV, comma separated, a series of comma separated values. When it got imported into SQL Server. Fields, the primary keys and second and foreign keys weren't set up. So one of the things that I did was I wanted to do something like this, to go into the tables, and you've done a little bit of this in your other homework. You go into the tables to add primary keys. So there's the script, or the SQL statement. And when I executed that after I had done the import, I got an error, because it turns out that the fields, when they're pulled in as CSV, it was a varchar, which is a varying length character string. The maximum that it saw when the import utility was 7, so it was set up as 7. But it was, by default, all the fields coming in from the CSV don't have any of the metadata associated with the fields. So the import utility just kind of makes a guess at it, and it assumes that the fields support null values. If you go to issue this guy, I've already fixed it, so it's not a good example. I can't really run this anymore, and I've already defined the keys. But what I did was try to define the keys, came back with an error, because that field, which was FID, or in carriers, it would be this one, CID, carrier ID, was a field that was could have nulls in it. And the constraint that SQL Server uses is it cannot be a primary key if you can have null values, and it has to be a value there. So that would have an error. So what you have to do is then go in and do some other manipulation, which would be to alter the table. This is what I did. And so when this didn't work, I kept it in the script file, but then I went back to do the alter table, and alter table, alter column. So this syntax check, this thing has got a syntax checker that's built in, and pretty quickly, I was able to work through it, create a script, save the script, send it to somebody else, include it in the setup, things of that sort. So if you were teaming up on homework 3, one person would probably be doing the work in this tool, or a similar tool if you're, but probably this tool. You can connect this into one of the connections. I don't think I have the connection here. So, but you can connect this directly to Azure. You can connect it to your local SQL Server databases. I normally have connections to multiple ones because I'm running it at SQL Server, a couple different places. And anyway, one person would be working on this, and the other person share out your screen, and the other person could watch what you're doing. Chris Nye, who was working on getting up the TA, was working on getting the Azure SQL and local install for the homeworks for homework 3. We did this last weekend, and I looked over her shoulder in SQL Server Management Studio. Chris, you share your screen out, and I can see what you're doing. So via screen sharing, you ought to be able to get that done. So okay, now what are people asking here? SSMS is an alternative to MS Azure that we can use. Now, SSMS is a client that this tool that we're looking at is a client that works with Azure databases, Azure SQL databases, works with local SQL databases. It works with SQL Server. It's called the SQL Server Management Studio. And it's a client and built in to let you navigate around your database. Okay? So it's a great tool. It does require Windows. If you go back to the letter I wrote, I'll republish this on Monday. I wrote you on our welcome letter. I mentioned the alternatives, and we'll get some of that. But VS Code, DataGrip, they have you can embed data tools like this into it. There's MS SQL kinds of tools, and you can get a very similar experience. But it's free. It's what everybody that works with SQL Server on a developer level, which I do, that's what we use. It's great. It's a great tool once you get the hang of it. And you kind of figure it out. There's help. You'll find that this stuff is well documented. Okay, now let me go back to where we got. We'll deal with. Thanks for telling us about GitHub. We'll figure out something on GitHub. Okay, let's get going. So that was a quick SSMS link. Here's the link for SSMS. Here's the link for Visual Studio. Visual Studio Code. And look for the MS SQL extension, and you'll get experience similar to SSMS. They're componentized. They're very similar. And you could get, I published the link for SQL Server Express. That's free. You can get that. I think you'll probably have a better experience if you download and you do they're giving a free 6-month trial that you could download of SQL Server 2019. I'll send out the links to that. There are Mac OS versions, Linux versions, and of course Windows versions. The 6-month trial, you might get some annoyance that somebody from Microsoft Sales will contact you and want you to buy SQL Server. You can tell them it's just a school project, and you'll get rid of them real quick. Okay, any questions about that? Are those brackets around? No, the brackets are around that. They, again, disambiguated, and that seems to be the way SQL Server SQL Server Management Studio likes to do it. What it does is it, whoops, come on. What it does in their syntax editor is it's a delimiter that they use, the syntax check editor, that the editor uses to detect things. I don't know why they use it, but for instance, I found that this flight small thing right here, that was real hard to get him to recognize until I put brackets around it. So I started using brackets, but I didn't use that for the other ones, as you can see. But other than that, because of this dash, I think, that bothered the syntax check editor. It's legal. It's not typical to do that. And you may notice that as you're working in SQL Server, there's a whole lot of reserved words in the language. And also the language is limited in terms of its character set. And that you get used to it after a while, but it doesn't support a lot of things that you would a full programming language does. Yet they have added a lot of constructs to it that make it like a full programming language. Not a programming language I love particularly, but a lot of people use it that way. T-SQL. Okay. Okay. All right. Let's get on to what we wanted to do today, because that's let's spend 20 minutes on that, unfortunately. Okay, where we been? The order in which we SQL statements are processed is from, where, the group by, the having, the sorting, and finally the select. And we talked about group by and we talked about having. The order matters, as we'll see when we're start thinking about different ways of writing a query, especially when it comes to performance. One of the reasons for adding the keys to the flights database is that the optimizer will know to use the keys, and when you do various joins, and it should run faster. This will be pretty important on SQL Azure, because those servers are distance away. You're going to have some lag time, contacting them, sending your requests back and forth. It's going to run a little slower than it's going to run, say, on my system here, where everything is right there. Okay. The last thing we looked at on Wednesday was what's called the witnessing problem, basically a pattern to get a piece of data, identifying data associated with a minimum or a maximum of some value that you picked up in your grouping. And we saw a really convoluted way of doing that. And what we're going to show you today using subqueries, which are basically fully whole kinds of subqueries, SQL queries that are embedded in other queries. And it's a way of assisting your queries. And when we get done with this unit, by the way, I should tell you that we're going to look at a couple of other constructs, but at that time, we will finish up with most of the basic elements of the SQL language that you'll need to write queries from this day forward. You'll have all the essential building blocks, really. And some of the things that we're already showing you, like I don't remember ever having, in my professional life, needing to use having for a query. Now, that's also because I'm a programmer. If I had a having, I might have done it in the code, but I was not familiar with that construct particularly until I started teaching it. So I don't know how widespread it is. Certainly I'm aware of what good it does for you, but I had no prior experience with it. Okay, so where we're going in this lecture is we're going to tackle the witnessing problem using a subquery. And having introduced the subquery in that context, you'll see it, I think, a much more straightforward way of writing out the query to get that result. And then we'll start talking about the mechanics of how subqueries work, depending on whether the subquery is in the select or in the from or in the aware or having clause, which are similar kind of conditional clauses as we've seen. If we get that far, I don't know if we are, but we'll talk a little bit about decorrelation and unnesting. And no, I don't have any notes about homework 1 yet, so let's ignore that. That's a previous author. Okay. So if you remember this problem from Wednesday, what we did was solve it in a relatively convoluted way. But what we talked about it was to do some kind of a join of this table where we added another column, which would be the max salary per job type. And that's effectively what we did, and we did it with a self-join. So, but with subqueries, we are going to basically have a different way of representing the same solution. When you start to get into the realm of subqueries, though, and I'm going to stress that I've mentioned it 3 or 4 times already in the class. We're talking about a relational algebra. It is, in fact, an algebra, and multiple solutions frequently exist. Sometimes, up till we had a discussion earlier in the week, and I was out on ED talking about it. We had 2 very simple ways of writing a join, 2 different ways of writing essentially the same join. It's a matter of semantics to me whether it's the same join or not. I said it's simple enough that the SQL optimizer, which turns your join into an executable plan, would generate the same execution plans for both joins. So it really doesn't, in that case, doesn't matter which way you write it, because the optimizer will figure it out for you and consider the plans and execute the best plan. What happens when you start doing embedding subqueries in your queries? The SQL optimizer is less inclined, I would say, because it's starting to get complicated, to figure out all of the different ways it could execute it. You're kind of constraining the optimizer as to what plan it's going to generate. And unfortunately, because of the complicating fact of the subquery, that's an added complexity to its job. And consequently, because of that constraint, what's going to happen is it's going to generate a plan that might not at all be optimal for your query. And so these may be different ways of executing the query, but some of them are going to run significantly quicker than other ones. And we'll talk about a couple of minor cases, but this is something you start to run into as your queries get more complicated. Okay, so our query here was to return the person for each job type with the highest salary, the max in that job type. And we talked about the best way is the group by technique, certainly interesting, but could we compute the maxima first and then execute a join? And in fact, we can do that with a subquery, and we're going to spend a little time on this subquery as well. So here's the subquery. And it's the first time you've seen this kind of construct, but it has a clause that says with. With identifies what follows as a table just built for the purpose of this query that we're giving a name of max pay. And then in parens, and it's as, so then in parens is the select statement that generates that table. And the select statement is pretty straightforward. We've got the job and we've got the max salary. We're going at payroll and we're doing that grouping. We don't have the name here. All we're doing here is getting the max pay per job. And then that table, it can be referenced in another query that does select, gets the name out of payroll P, and gets the salary basically from the max salary from max pay. And it's doing a join at that point between the payroll table and the max pay table. And it's matching on job and it's matching on the salaries as well. So let's look at that in a little bit of detail since you haven't seen that, and it's probably confusing until you execute it or you write it yourself. As I said, we're starting with this with, which now creates a query. The result of that query is a relation. That relation can be in a second query that references it down here. And the syntax and the effect of that is that the SQL syntax checker goes, max pay, where is that? Oh, max pay is this, and we'll generate an execution plan that does this select first so that it can apply it to this join down here. Now, I'm sure you have a bunch of questions about that, but that's how this works. Let me see what you got here. Can you make multiple subqueries? Oh yeah, you can nest them as deeply as you want. There's no restriction on that in the language. And queries start to get very, very complicated as a result. So we're keeping it pretty simple here, but I'm going to argue that this is actually a somewhat more, there's a little bit more text involved in this, but I would argue that this is a simpler way to solve that query, solve that particular problem. You do have to, when you reference, the question is, does that with have to be in front of it? And the answer is yes. The syntax checker gets down here, and it must know that the max pay is there. So I believe that is a restriction. Everything that you're withing has to be above where you first reference it. It's like having your variables defined before you reference them. Here you're actually creating a temporary table called max pay. And yes, you've got to define that up front. Okay, all right, I'm going to go on. Now, so when we talked about the way this was handled when we had the halving, remember that was a self-join. So then the question that I thought maybe people would ask is, well, is this a self-join? Well, yeah, if you notice, this is payroll here, and this is payroll here. But is it a self-join? Well, not really, because the join now is with a smaller table that only has one row for every job type, for every distinct value of job. So actually, this is more efficient than the group by, the way we did it before. Because when we worked out that, we had to do that self-join. If you remember, all of a sudden, we had to join everything to everything. At the level of the job, because that's where our inner join was, how our inner join was written. So this is actually more compact when it runs, because it will compute this, create a smaller relation, that's only one row per type, and that's what's being joined here. So it's not really a big self-join. It is a self-join to the extent that payroll is in both places. So I guess you could answer that both ways. It's a self-join with a qualification, and it's done much more efficiently than the group by. Again, if you're looking at 5 or 10 names, it may not matter. If you're looking at the payroll for, I don't know, the Department of Defense in the United States that involves a couple million people, yeah, that's a complicated query. Then this stuff really starts to matter. Big data. Once we get into big data, a lot of this stuff matters. And what may not be apparent to you because you haven't done much SQL programming yet, but one maybe not obvious benefit of the subquery approach is I can formulate my approach like let's do a join, and get it working incrementally. So the way I would probably do that is that this. Whoops, sorry, go back. I thought I was in my editor. You would do this select first, maybe, or even them both separately, and individually debug them, and then do the join and put them together and see that you had the right way. So because you can develop it incrementally, get a piece of it working, then you just wrap it into a with, and then you can reference it later. It turns out to be a better way to develop your query. So especially with the GUI-based tools that I was showing you, like something like SSMS, and that's typically what people want to do. So yeah, that's another benefit of this approach. And I'm not sure I had targeted this, but this is Pooh feeling this way. This is the way we did it Wednesday. I would argue that this is a little bit more intuitive. And this is kind of showing up a dressed up bear, I suppose, and maybe he's more sophisticated approach to it. Maybe, yeah, well, I try to keep it simple, and this to me is simple, and plus has the benefit, one, I think it runs faster, and two, because I don't do that massive self-join, and two, I can develop it incrementally, and that's a big benefit to me in terms of getting my syntax correct. Let me stop for questions. All right, we're good. Okay, good. How do you know what runs faster? My friend Lauren says. Well, we're getting to that. Hold on, we'll get to that. But what I could do is, a simple test is to write the query this way, execute it against a table with 1,000,000 rows in it, and it comes back, Saturday, and then write it some other way and it comes back Sunday. So that's one way that you can tell. But another way you can tell is what's known as the plan explain. And that's where we're heading. Understand that when the optimizer generates an execution plan for you, and one of the things that's made SQL Server very, SQL itself, a relational database is very successful, is plan explain. Yes, you can specify all this stuff in a very logical way, and you can say, you got this data independence principle, and so it doesn't matter where the data is, but it does matter. It does matter when you're executing against big data. It matters a lot. And my goal in this class, and none of this is in the book, my goal in this class is to get you to the point where at least you appreciate the value of explain and maybe even understand a little bit about what it's doing. So that's where we're going. The reason it's not in the book is they would have to delve into how it's done in every particular database. It's done a little differently in Oracle than it's done in SQL Server, and the optimizer is one of the proprietary jewels of these products with a whole lot of work beyond it. Okay, good question. Anyway, what you're doing is this is it's another way of talking about it, a useful intermediate result. Let's quickly run through how this would work. So just walk through it. Here's the result of this is max pay of that query is going to look like this. And this is going to be joined to this payroll, the original down in the second step. So the first query computes this, max pay. And yeah, it kind of makes it easier in my view. I think most people would agree that makes life a little easier. So some details on subqueries. Can subqueries be nested to any arbitrary length? The answer is yes. It's a computer. As complex as you make it, it'll do it. Could it get into a loop? Could it do any of those things that drive you crazy? Yes, it could get into a loop. There are looping facilities. Yes, you have to debug these sometimes, and SSMS has a debugging feature to it. You could be, so by a singleton, I mean that a return value, and this is frequently what you do in a subquery, is you find out if some condition is true or false by issuing a subquery. And so it might be that the only thing you care about is whether in fact this particular piece of data exists for that person or for that thing that you're querying. So it can be a singleton, and that's frequently done. It's a way of making your where logic a lot easier by doing a subquery that then just returns true or false. But yes, it can be used as input for another query. It can also be checked that the relation contains some specific value. Conditional execution, I only execute this subquery if this is so. And all of this begins the process of SQL semantics, the SQL language semantics, expanding from not just data manipulation, but to encompass more general purpose programming constructs. And be careful is my warning, it's a slippery slope. What I see a lot of people who come up and they start working in a database at their job, and the only programming language they tend to know, they learn well, is T-SQL or whatever it is for your, I think it's PL SQL in Oracle. They learn that language, and then they try to solve all their problems in T-SQL. And it has other aspects of things like T-SQL. It doesn't, componentization and things like that. Although actually in SQL Server, they've added .NET to it, so you can call .NET components. But so people do use it. I don't recommend that you use it, but your mileage may vary. Okay. So we're going to look at, so that's the basic idea behind a subquery. How are we doing on time? Ooh, way behind. So let's go through quickly a few more things. One is, remember that SQL mimics set theory, comes from set theory, but it's not really set theory, because if you had a set, duplicate rows aren't allowed, but in SQL they are, so it's really bags, but the difference is the distinction is not really worth much of a difference. Let me quickly get to this, though. We're going to look at, you can do, because it's a set theory, there are SQL operations, set operations like union, intersect, or accept, that are available. But with this caveat, in fact, intersect all, accept all, not support T-SQL, even though it's supposed to be. Another area where T-SQL is not particularly standard. Basically, something like union slaps two queries together. I'm not sure it's really a subquery, but it's a set operation. Okay. I got 5 minutes. Okay. With you subqueries. Now let's talk about the rules of using subqueries. When you use a subquery in a select statement, I haven't shown you that yet. I showed you the with. But you can use a subquery in a select statement, and it has to, though, because select works on individual fields, attributes of your relation, then that kind of query, a subquery in select, also must return a single value. And it's used to compute some kind of associated value sometimes, true or false or something like that. For instance, here's an example. It's not a particularly great example to use, but it's an example, again, playing with the same data, where what we wanted to do was get the average salary for that person. And this is a valid query. That's probably, again, not the way I would do it, but that'll work. Okay, so that's your it select, and this will return one value, which is that salary. Okay, the average of all the people in that job. Just like average works anyway. So that's another way of doing it. It's another way of doing it. The same thing. This in particular is what's known, there's a section in the book on this, as a correlated subquery. The distinct why correlated subqueries are important is usually performance, which is a hint that it's not good. And that's because this query is going to execute not once for every value of the job type, but it's going to execute once for every value of name. And there's a faster way to compute it, which is to compute it for the job, what we did before, and then bring it using a merge. And correlated subqueries are like that. So it's part of the loop that if you think about nested loop semantics, and if you have within the nested loop semantics another subquery, and it's going to be executed for every row, every condition, that is usually not less than optimal. So that's known as a correlated subquery. And so I've introduced a couple of performance things. Lauren doesn't believe me about it, but what we've talked about so far with self-joins and correlated subqueries, they both can be expensive. And then the other caveat associated with is, what happens is, yes, when the relational algebra starts to get complicated, you can no longer count on the optimizer to bail you out. A few more, I might be able to get it. Yes, the subquery is recomputed for each tuple. That's a worry. That's a concern. I'm going to skip this walkthrough right now. I want to show you some more. We'll go on, but we'll walk through that. You can see how it would actually be computed. And I don't think particularly, for instance, we use this query as an example there and did a walkthrough. So this is this is computing the average salary. Well, if I compute the average salary, why do I want to report the names? Well, I might want to report the names if, in fact, I got the salary in there as well and wanted to compare your salary to an average salary. That's more like something somebody in HR might want to know about your department or something like that. Not necessarily the example that we worked through, but it was more of an abstract thing. So you can have a select, and you can also, as we saw with that, you could have done that a totally different way with a self-join. So, and a self-join is also expensive, as we saw. So, but the correlated subquery, probably more expensive, but I don't know until I actually look at explain, test them, which is preferred. Yeah, I don't know. Sometimes it's a matter of personal style, except when performance is an issue. A key point here is, here's a query that's looking at, are these two the same? Here's where we're doing a join, getting the number of people, the number of cars they drive, because here's select our car. Are these equivalent? Here's another way of doing it without the subquery. Well, the problem is that the bottom one is forgot that count equals 0 is an edge case and would be discarded, because this is being done as an inner join. If those rows that don't have any cars are not going to be joined. So in fact, they're not equivalent, but they would be equivalent if this one was written with an outer join, which I think we do there. If you added a left outer join, yes, you could. Okay, and let me quickly show you one or two other slides. And I'll come back to this on Monday, which was no, I guess I passed on that. I guess I wanted you to know this kind of thing, which is there is from predicate calculus something like exists, and this is something that comes up. So you want to say, I want to take this row, but only if there's a corresponding row in another table where it exists, or something along those lines, having to do with your where clauses and things of that sort. So you often find the not in or not exists, and that's a frequent use of subqueries. Okay, that's all the material I think we have time for today. We'll start there again on Monday. Are any questions while I've been ripping through that material? I'm sure it was all perfectly clear. No? All right. I will shut down this meeting and go over to the